Hello friends, in today's question, a body of mass m moving with the velocity v in the x direction collides with another body of mass capital M moving in y direction with the velocity of capital V. They coalesce into one body during a collision. Find part A, the direction and magnitude of momentum of the composite body, and part B, the fraction of initial kinetic energy transformed into heat during the collision. So let us do it for part A. The part A, we are simply going to use the conservation of linear momentum. Okay, we can say conservation of linear momentum let us suppose that momentum is given as P and we have two bodies, momentum of small mass Pm moving in x direction and plus momentum of capital mass M moving in j direction. So we substitute the values because momentum is mass into velocity. So we can say Pm is equal to small m multiplied by small v unit vector I, and capital is capital multiplied by mass and velocity unit vector j. Now we can find out its magnitude. So P magnitude will be equal to their square plus mb square and its square root. This is a magnitude of the composite body, and in this case we can clearly see that P is our final momentum when the both are combined, and the right side is their initial momentum, that is momentum of small mass and capital mass. So from here we can say that is equal to final momentum is equal to initial momentum. Final momentum is represented by P. So P is our final momentum, which is equal to initial momentum, their individual momentum sum. So we got their magnitude, and let's find out a direction. So we say, suppose alpha is the angle with positive x axis. So we can easily say that our alpha is equal to tangent inverse of momentum in y direction divided by momentum in x direction, or we can say tangent inverse of, we have capital M into V divided by small m into V. This is our direction. You can say this is the direction of the momentum for composite body, and this is the magnitude. In the B part, we are supposed to find out the fraction of initial kinetic energy transformed into heat. or basically we can say loss in the kinetic energy. So B, we can say fraction of kinetic energy which is initial transformed into heat energy, or we can simply say loss in the kinetic energy. Loss in kinetic energy, which can be written as kinetic energy final minus kinetic energy initial divided by kinetic energy initial, which can also be written as kinetic energy final divided by kinetic energy initial minus 1. So we already know the final momentum is given as P, so we can denote the kinetic energy with respect to the momentum. So we can say this is equal to P square divided by 2 m plus capital M divided by initial kinetic energy will be kinetic energy of the small m plus capital M. Or we can say half m v square plus half capital M and v square. This half and half goes with this half. Therefore, you can say that this will be becoming equal to as P square, this will be m into capital M, and we have mv square plus capital MV square, and value of P we already know, and it is square. We can write this as MV whole square plus capital MV whole square divided by M plus capital M, and we get this as MV square plus capital M V square. So this is the fraction of initial kinetic energy transformed into heat energy. This is the fraction of initial kinetic energy transformed into heat energy, or which basically means loss in the kinetic energy. Loss in the kinetic energy. So this completes the question. Thank you.